and welcome to the lecture 22, the final lecture of the Learning About Learning lecture series. In the last lecture we were talking about emotional memories, how our brain is capable of storing the contextual information or the information surrounding the emotion separate from the emotional variance itself. We saw that hippocampus stores the contextual information while the valence itself is stored in amygdala. Following which we were talking about second order conditioning, a phenomena in which a conditioned stimulus, a stimulus to start with did not have ability to elicit a response on its own in the given context. However, upon pairing with an unconditional stimulus, it acquired a response. You created a behavior in that animal whereby you are able to elicit a response by presenting a stimulus until that point is which was very naive. Now you take that stimulus, the stimulus that acquired this new response, and then pair it with another stimulus, again another conditional stimulus, that is the stimulus to start with does not have a native response. Now when we do that, what we saw is that you can actually now elicit a response, a similar or a different response for the new stimuli, right. The new is intentional here. I am talking about new and new, two news here, because the first new is about the first conditional stimuli and second one is about the second conditional stimuli, and since it is second order, it is not directly linked to the US, but it is linked to through the CS1, it is called second order conditioning. For definition's sake, it is nice to think in terms of connection through the first stimuli to the US and all. However, research from various different laboratories has shown that this is a memory by itself. That is to say, one can go ahead and modulate the first memory, the memory associated with the first stimuli. If it were to be directly linked, you would say that if you were to modify the first one, it should reflect in the second one, right. But what we have seen is that that is not necessarily the case. For example, you can tone fear condition an animal and then second order condition the tone to a context, go ahead and extinguish the tone fear conditioning, you would still preserve some amount, you will preserve the second order conditioning that you have acquired to the context through the tone. So clearly it is not it is not that simple to say, hey, they are linked in a chain. That is not clearly the case. Let us see an example of an auditory fear conditioning and how it is actually very natural for the second order conditioning to fit in this setting. Okay. What I am going to show you is a set of videos here illustrating some of the behaviors that we talked about, and first of them is the auditory fear conditioning, and then I will pause a minute and then explain to you the context of the second order conditioning, what happens here, and then go into some other behaviors that we do in the lab and many other labs do to study learning and memory. Good. So the first video is of tone fear conditioning. So let me try playing the video here. What you are going to see is that we have tone trained the animal, that is we have taken this animal, put him inside a chamber, played a tone, and towards the end of the tone we have given mild foot shock. Now what we are going to see is the video of a testing trial of this animal. Okay. So we have taken this animal, now put him in a different chamber. Please notice this triangular structure here and then a flat white sheet underneath. Both of them will be absent during the training, that is the definition of context A in our lab setting. What you will see is the small grid of steel rods defining the floors, and there is no such sheet that you see right here, right, that will be absent, and this base will also be absent. Both of them will be absent during the training, and then when we play the tone, towards the end of the tone we present a mild foot shock. Now here what we are going to do is we are going to test how well this animal has learnt. So now, because it is a new environment, because of the presence of this triangular shaped structure, and together with the fact that there is this the base of the chamber is different, and not just this, there are also things like the smell of the air, right, the olfactory stimuli, that will also be different, and the noise, the background noise, we run whenever you are going to a lecture hall which is not air conditioned or something like that, you will hear a hum noise, right, from the fan. So such kind of a hum noise can be present or absent. They define two different contexts in our case. So all such things, the light can be turned on and off. If you are wondering how can you record a video when the light is off, these are infrared sensitive cameras. So there is an infrared light that can actually be detected by the camera but not by the mice. So all by varying these conditions you can actually make the chamber look different for the mice. In a sense, you are creating a different context, and you have created a different one such different context here, and then we place this mice here inside this context. Now what we are going to do is we are going to wait for a few minutes before the start of the tone. During that period, the mice is going to, what you will see is that the mice is going to explore, suggesting that it is not expressing any fear because it is freely moving around. Upon the onset of the tone, you will start to see change in its behavior. It is not a continuous change in the behavior, but you would see a discrete change, but whereby the mice will take a typical hunched position and try to be in a motion where completely restricted, there is no I mean it is free cessation of all movements except for respiratory motion. That kind of episodes will be happening much more frequently. In fact, you will not see any episodes at all during the baseline, and once you play the tone you will start to see that episode. And in this case, in this particular mice, when the tone goes off, you will also see that it will quickly relax back to its original state of moving around freely. Okay. So let us go ahead and see this video, and intermittently I will give you or tell you what is happening here. So that is a normal behavior of the mice exploring a new environment, and that is what you see here, and that is going to keep happening for some time here being about a minute or minute and a half here. And so moving around exploring this place. Now he starts to occupy that position, and you can see these are the freezing episodes. As you can see, it is not a continuous episode, but it takes the freezing position, little bit relaxed, comes back, it goes off and on, but the episodes are clear. Now the tone is off, he will start moving again and exploring this place. So now that is what we measure. What we do is in a lab, every 1 second of the video is analyzed, and you ask if the mice is expressing the freezing behavior in that 1 second, and thereby you can actually measure how much of the what fraction of the time the mice is spent freezing. Now what we have done here is that I told you that by changing various different factors, we have introduced this animal to a novel environment and then played this tone, and the tone elicited the fear. Okay. This fear in turn is transferred to this new novel environment. So initially you saw that the triangular box defining a new context, the animal is moving around very freely, right, which is not the original training context. Context A is the original training context. Then we gave a 24-hour gap for the consolidation to take place, and then we put the animal in context B. It is important here to note that it is a different context here. Then this is the testing context. We played the tone, elicited the fear. Having elicited the fear, this context, the context B, the next day when the experimenter goes and tests this animal, you would see the animal exhibiting fear. You can measure its freezing episodes, and you will see that that goes up, and that clearly is second order conditioning, because context B is never exposed to the shock at all. It is never shocked in the context B, but still it expresses the fear just because it has been tested on the tone. Now this is where I was telling that it is not a direct link, because you can go ahead and extinguish the tone fear memory. Even after that, the context B seemed to preserve the fear. With that interesting thought, I will let us move on to the next behavior, and then how the videos of showing how exactly that behavior is done in the laboratory. We have seen this behavior before. This is the water maze behavior, where we are testing the animal's ability to use the extra maze cues and then make an association to the platform, the hidden platform inside the pool, and then how the animal actually navigates itself to reach that platform after remembering where these cues are and so on. So, what I am going to show you here in the videos is sets of I mean it is a two video. One recorded on the first day, very first day when the animal is trained or exposed to this training on this pool, and on the 10th day. Okay. So, we are looking from the top, and the black dot you see is just this you are able to see because you are looking it from the top, and then just to make our job easier for as an experimenter, you are actually having this mask here, you are able to see it, but for the mice it is not visible, and you will not be able to see it. So, what you will be seeing is that how the mice is actually swimming around all in this place, mostly going in circles and not being able to know where the platform is. However, over a period of time, that is about after about 10 days, where you can actually see that the mice is able to find this platform much faster. In fact, this kind of ability to find the platform faster comes even little earlier, but we are here showing you the 10th day just for our own convenience. Okay, let us go ahead and watch these videos, and what I am going to do is I am going to play the first day video first, and then the 10th day. So, the mice has been dropped, as you can actually see that the it is going around. This is the wall hugging behavior we talked about. They are a little anxious, they do not like to come to the center, but they do come after a few minutes, and then they just do not know where exactly the platform is and what they how they are supposed to reach there. So, they keep going round and round without knowing where exactly to reach, and we leave the animal for about a minute here. So, towards very end of it, sometimes they find it, yeah, right next like that. But on the other hand, if you look at the 10th day, the animal has been placed in the water maze and it just makes a quick turn around and then there you go, bingo. So, that is how they can actually learn. It is very marked striking difference in their behavior compared to the 0th day, and the real way of, I mean the way we measure the performance, this is measuring the performance of the mice, the way we quantify the memory per se, the memory strength per se, is by doing a probe trial where the platform is removed and then we ask how often the mice is swimming in that particular platform quadrant, right. We have seen that in the previous lectures, and that this is how it has been done. So, these are the few videos that I would like to I wanted you to show, and then so that to get the feeling of what exactly we mean by small animal behavior and how, what are the parameters that we use to, and how we extract those parameters from these videos. I also said there are behaviors which probe the animal's ability to socially learn certain aspects of their life. We talked about we talked a little bit about this along the Garcia and Collins line of how the animal tries to learn, tries to defeat the bait that the farmer is giving in terms of poisoning the food, and once it understands that it is eaten the poison, how it does not go back to the same place. And in that context we also said, okay, is there a possibility that this can be in the whole idea of that existence is because of the ethological relevance. So, along those lines one can argue that is there a possibility that somehow this learned experience could be transferred to its fellow rats or the mice or the rodents, then that would facilitate the species as a whole, and has the brain evolved to do that, right. We do learn, right, and I mean we have an experiences of social learning in our own case, and the point is do the mice exhibit, and if they exhibit, how do we go about testing it. To this end, people have devised early methods, again looking at the ethological context of how you can transfer this information. It is called a social transfer of food preference. Traditionally it is done in a way such that you would be able to say if the animal has changed its preference or not. As we took on this field, and our own laboratory has changed these methods and improved its sensitivity. As a result, I am going to present to you the paradigm that we use in our laboratory and that we have changed in our laboratory, but overall idea remains the same here. So, let us look into that and to give you a feeling of what exactly we do we mean by social learning. This hinges on the very same idea of bait signers or the inhibition to explore something novel, right. So, there remember the rodents, if they are smelling or tasting something different, they would like to taste it in a little bit, not too much. They do not like to go into a new unexplored flavor, okay, neophobia, right. But too much of neophobia is not good because it does not allow them to expand their palate. So, you need to overcome that. There is a tendency to overcome, but then to start with there is this neophobia. So, now what people have done is that they made use of the fact that if an animal, one of its conspecific, has eaten a new flavor, somehow its own conspecific understands that the animal has eaten that new flavor, new food, and it is still alive, nothing has happened to it, and even more better, if it is really rejoicing it, then somehow if it could convey that message, it could identify that message, then the new person can go ahead and eat it. So, now that is the behavior that they wanted to test. So, in order to do that, what we do is that we classify the animals in two groups. Group A, we call them as observer mice, and group B we call them as demonstrator mice. So, what do they do? So, let us take two different flavors to start with, let us say flavor A and flavor B. Now, expose these two flavors to a given animal indicated in black here. The animal would like to eat either one of them, they would eat both of them, but they would eat one more than the other, very unlikely they both they eat more or less the same, but everybody individually is slightly different. So, somebody likes A, somebody likes B, but the point is there could be a variance and among the population, and we can actually, if you monitor video through videos, we can actually see who is spending how much of the time eating which of the flavors. By quantifying that, you can say, okay, the person or the mice observer mice 1 prefers flavor A, observer mice 2 prefers flavor B, so on and so forth. Now, the idea here is, having observed that observer 1 prefers A, I want to see if it can switch its preference from A to B, because A is its preferred flavor. Can it switch to B if it knows some other conspecific has eaten B and then nothing happened and they really enjoyed? Now, how do you do this? What we do is that we take the another group of mice. The group here is represented in green, and we feed them with the opposite flavor, the less preferred flavor of the observer. So, if you take an observer 2, there is a matched demonstrator, let us say demonstrator 2, who is going to eat a lot of B. When it eats a lot of B, so we feed them with B. So, we say that A preference is greater than B. So, then what we do is we feed them with B. Then once we feed them with B, we make them interact. The interaction is very simple. We take the demonstrator mice and leave them in the cages of the observers, whereby the observer gets to smell the leftover particles of the food pellet powder flavored in B, along with the post digestive gases that are coming out from its the demonstrator's stomach. The observer now makes an association between these two stimuli, the digestive gases that come out from the demonstrator and the flavors that are left over on its whiskers and on its body. So, the next day you give them a choice between A and B, okay. Then it is pretty much like same as what we have done for estimating the preference to start with. Then we ask, is A more preferred or B more preferred? When we do that, what we have seen is that if you ask 24 hours later, and if the social interaction were to really work, you would expect that they would switch their preference, and that is precisely what we see. What we are seeing is, for every animal we are actually measuring the preference, and that is the level of preference. Okay, it is in some units, it is basically the number of frames that you see the animal spending on the preferred flavor, on a particular flavor, and what you see is that is the starting flavor before the social interaction, and after the social interaction 24 hours later you give them the preference, I mean give them the choice between A and B. Clearly the things that they have not, the animals did not prefer B, has increased its preference for B, establishing the fact that information in the form of learning can be transferred through social means, through social interactions, wherein the person or the subject per se has not directly get exposed to the stimuli or the situation that was presented to him or her, but still can learn from the experiences of the other. With that, I would like to conclude our learning about learning lecture series. We started off by asking how can we test or how can we even know that memory exists in the brain, and we went all the way to formulating a testable mathematical description for explaining how a learning can happen through and then the correlations for the experimental behavioral measurements that we can make, and then relating it all the way to individual molecules, how they can actually dictate and modulate the behaviors of this of the animals. And towards the end I showed you some of the experimental methodology that we adapt in the lab, and some practical feel for how things are done. I enjoyed talking to you guys through virtual means, and I hope you enjoy listening to us. Please let us know what you think, and we will be happy to help you with any questions or comments that you may have. Thank you.